Awesome, thank you. Thanks for the lead-in, Aspen, as well. Perfect lead-in for this. Really appreciating if everyone get here as well. Nice full house. This is the first time I've spoken in public for several years in Melbourne, so that's great. Thanks for the invite. I'm going to talk about schemas and not contracts. Great lead-in from Sol. So, quick show of hands. Does anyone here know what contract testing is? Hands up if you do. Use Pact before? Okay, maybe 2/3 of the room. You will get the most out of this talk if you know the concepts. I'll briefly touch on it. And of course, if you have any questions, come and talk to me afterwards or ask in the session afterwards and we'll go through that. I've also got some colleagues here, so come and find us. My name's Matt Fellows. I'm the principal product manager here at SmartBear. And I was the co-founder of Pactflow, which has been part of the SmartBear family since April. And I'm also a core maintainer of the Pact open source framework. So I'm a recovering consultant. I spent 7 or 8 years doing that at my previous organisation, DS, and I got to do some really great stuff at a bunch of really cool Australian companies, working in cloud architectures, RESTful microservices, IoT, data pipelines, all those things. And while we used to introduce contract testing in those cases where it made sense, where we could help customers move quickly, solve bugs, deploy into production, all that shift left movement, we would do that often, and it was great. But occasionally we'd run into this question, usually from some other consulting, person maybe who had different ideas, and they would say something along the lines of, if we just used insert blank, then we wouldn't need contract testing. And the idea here is that RESTful services maybe aren't, maybe it doesn't solve our problems. It's not as secure and reliable as we think, and the fallibilities in that could be solved by using some newer technology. So today we're going to dive into that. We're going to see, is this true? Is REST really the problem? Is it something else? Can that solve it for us? And we're going to look at 2 types of technologies to see how, or two classes of technologies, to see how it actually doesn't really solve the problem. They introduce a whole bunch of benefits, but they're not going to solve the issue we're looking for. Specifically, we're going to look at specifications and schemas such as OAS and things like SOAP and async API that stem from that, and IDLs, so things like Protobufs or Avro or Thrift and those kinds of things. Let's start first, though, just by sort of thinking about the modern challenges of today and sort of what we face as engineering leaders and implementation practitioners. I'm going to start with a quote from a customer who reached out to us. I think this was last year. I think it sets the scene for what I want to talk about today. So you can see that this is a Pactflow prospect. This guy reached out. We're going to protect him, protect the innocent. We'll just call him Bill. Bill's the leader of a testing organisation for about 40 different teams in a large banking organisation. And you can kind of just get a bit of a sense here, he's working in this very complex environment with a lot of teams, and there's just software everywhere. There's RESTful services, there's GraphQL, there's Kafka, there's messages, and you can sort of get this sense that he's just really working in a chaotic environment. Like he's looking for some ways to bring process and control to this whole system. And if this sounds anything like what you guys are experiencing now or day to day, then you're not alone. Research from SmartBear State of Quality as well as Postman's State of APIs kind of backs this whole up. And you'll see that a large proportion, about 60% of respondents, indicate that the growth of services and APIs in their organisation over the next few years are actually going to be internal microservices, not public APIs. And this is really sort of reflecting the benefits that internal microservices bring to an organisation, similar to what we did with public APIs over the last decade. We found that by opening up APIs to the world, we could really enable use cases in a public ecosystem. The same thing's kind of happening inside organisations where we're sharing data and building these new use cases internally. In addition to that, we can see that most companies now operate in a multi-protocol environment. So they might use REST, but they might use Kafka or Protobufs or something else, right? And about 60% of those use 3 or more of those protocols. Now that all sounds great, but of course, microservices aren't new, and we've learned a lot of lessons over the last decade about how to run microservices at scale and how tall you need to be able to build a microservice, all those kinds of things. But there's this long tail set of challenges that we're kind of running into now as an industry. We can see that about 53% would state that skills were a barrier to entry to building these microservices, as well as the complexity of the system has increased so much that that's also contributing to building them well. And in terms of obstacles to get the software out the door, 1 in 2 will cite issues with how long it takes to actually build that software and get it out, and the pressure required to do that, as well as they're feeling the pressure to this increased demand for speed and time to delivery. So cycle times, lead time for change are really putting a lot of pressure on organizations. What I found the most interesting is that bottom fact. You can just Google, by the way, state of APIs and state of quality. You'll find them if you're looking for that. So don't worry about looking at the graphs. What I found really interesting is that the mature organizations are the ones who are feeling the most pain, even more so than new organizations, which sounds really counterintuitive. Why would it be that mature API orgs with good engineering functions are now running into issues with all of this? And I think the reasons for it are really well understood. One of those is about how we test software today. And usually speaking with distributed systems, the predominant mechanism of doing that is what we call end-to-end integrated testing. So for those of you who've seen contract testing, this is the contract testing pitch. You can just tune out for 2 seconds. But basically, end-to-end integration testing involves taking your software, putting it into a test environment, running a battery of tests against that, and checking to see if that worked. And you run that across all these scenarios. And of course, if that works, you get a high degree of confidence that your system works as expected. But of course, it also comes with a bunch of downsides. They're slow, they're fragile, they're hard to debug. You usually need to deploy things together if your testing's this way, which means you've kind of got a distributed monolith. And you can't deploy them independently, which is really important. And this feedback just happens a bit too far right in this SDLC. So it's not that these things are bad inherently, it's just that if they get used as the only way of testing your services, you're going to run into some issues. And what it does, it creates this problem as you start to scale. So as you grow your ecosystem, the number of people and teams and components and applications in your software ecosystem, what you find is this non-linear response to things like the cost, complexity, time associated with, or number of environments, build time, the risk associated with a particular change, and developer idle time, queuing and moving between deployments and work items, right? We know that queuing is really bad for agility. And if you look really carefully, you see only at the far right-hand side of the diagram, where the inflection point is, that is where the pain hits, much later than the early life cycle. So no wonder Bill is having a bad time. So this is kind of where contract testing can come in to help reduce that pain and give us faster feedback and bring something to this chaos, right? And the way it works basically is we're going to write a series of unit tests. The way contract testing works is basically a series of unit tests on one side where you mock out the other side. And those mocks essentially become a contract that says, this is all the things my consumer needs. We replay that against the provider side, the API producer. And if it can do what it says in that contract, we're feeling really comfortable that the services can communicate to one another. Importantly, we can track this over time as well. So it gives us a way of evolving our services safely. Okay, so let's return back to the original argument now. We've had a bit of a backing in the problem and why contract testing might be able to help us. And we'll return back to that hand-waving argument of, is REST really the problem here? And if we just replaced it with something different or better, would that make this problem go away? Can we avoid having to write tests, right? We'll look at schemas and specifications to begin with first. So we'll start with OpenAPI, which hopefully I would imagine this audience is really familiar with, as well as JSON schema, which works for that. But this really works with async API, SOAP, to an extent GraphQL, these kinds of things. So how does an OpenAPI and a specification help us? It has a few things. It's a human-readable format, and it's a computer machine-readable format. So humans can read it, understand what an API is supposed to do, and computers can as well. So we can do a bunch of things that because the computer knows what it can do, we can do a bunch of really great things with code, for example. Because it's paired with JSON schema, we can now know the shapes of incoming bodies, right? We know what can go in, we know what can go out, it's a schema, right? And because it's machine readable, we can generate clients and servers from this. We can generate code from it that's going to be tied to the specification. That all sounds really good. But so if we can generate that from a spec, then why do we need to do something else? Aren't we guaranteed to always have a working system? Of course, the answer is no, otherwise we wouldn't be here. But if you're old enough to remember SOAP, like I am, maybe, you'll remember that it didn't actually solve this problem. It had all those same ingredients. It had a specification, it had a schema, and you could generate clients and servers from that. And of course, that still didn't go away. Now, REST does have a bunch of additional redundancy principles built into it, or better redundancy built into it, like Postel's law and extensibility. But ultimately, it's still building on a lot of those similar foundations. And we'll talk about JSON schema to help frame this, but even if you look at the JSON schema docs, it basically says you need two types of validation. you're going to need the structural one, which is what JSON schema gives you, and you're going to need a semantic one, which you're going to need to do with code, basically. So it kind of says, just make sure you know this is what it's good at and what it's not good at, right? I think it's important to understand what tools are good at and what they're not good at, and how to build all these trade-offs into your testing. We like to think of we like to use an aphorism, which is basically, and your API is not incompatible with your spec, which sounds really clumsy. And the reason for that is specifications are actually abstract, as much as we like to think they're not. So a good example of this is optional fields and polymorphic payloads. If you have a body that says, here's all the things you can do, and these are optional fields, at what set of optional fields that go in and come back, it's actually hard to know when that's going to be the case. And some consumers may really need those optional fields. So you actually lose out on this kind of level of completeness. And the second one is polymorphic payloads. And of course, if you combine those two things together, you get a much more ambiguous situation. These are the sets of inputs that can go into a single endpoint. These are the sets of outputs. And it's actually hard to say computationally that we've implemented the right thing. You need an extra layer of validation there. The next set of problems we've got here is losing sight of the API surface area. So if we don't know what our consumers are doing with our API, we have to assume they're using the entire API, right? The entire surface area. And so then we have to use things like versioning to make sure we don't break it later on. Of course, there's other strategies to try and get this information, but they're usually difficult. And the last one around client SDKs. So I was talking to one of our solution engineers in Europe, and he told me that basically 90% of the customers who use client SDK generation will actually modify that after the initial generation. So they'll generate it, and then they'll just tweak that by hand afterwards, because it's actually easy for them to do that rather than replace the whole thing, which might have other impacts to the code, right? So there's still this opportunity for us to introduce breaking changes into the system on either side. So just briefly on versioning, this is probably the predominant strategy in terms of what people would use to avoid breaking changes in their APIs. That's from the Postman survey, I think. And that's fine, because we need to think about not breaking customers, right? It's not a good thing to do. But versioning is very expensive for an organization to support. You have to build a new version, you have to test it, you have to release it, and now you have to maintain that alongside all of your other code as well. And so there's a long-term cost that you have to wear every time you version an API. If you don't know what your consumers are using, the only opportunity you've got is to bump the whole version, right? At some point later on, you have to bring the new consumers onto the later versions, have all the communication. So all this overhead is expensive, and if we could avoid it, we really would like to do that. All right, so let's talk about the second class of issues, which is around IDLs, and we'll use Protobufs and gRPC probably as our pin up here. And we're going to build on the same lessons we just learned from OAS as well. IDLs, such as Protobufs and Avro and Thrift and flat buffers and so on, have basically then one of the main things they do, aside from high performance, they also have different use cases, is they build with schema evolution as built into the protocol. So Avro, for example, you can write files to a system and it saves the schema with it. Protobufs has a binary protocol that it factors all this into it and gives you forwards and backwards compatibility, which is really cool. And of course, because it's a machine-readable thing, you can generate code from that, right? So you're probably going to get a sense of the kinds of challenges we're going to run into here. But if it's true that they can do that, why was it our #1 feature in the Pact open source roadmap for about 3 years while we built support for it? Well, you can imagine, the reason is that colorless green ideas sleep furiously. And if you're wondering what the hell I'm talking about and what this statement is, that's fine. It's basically an absurd statement from a guy named forgotten his name, Noam Chomsky, from his psychological dissertation in the 1950s. Basically, it's a point he's making that syntax and grammar and semantics are different things, right? Syntactic well-formedness doesn't mean that you can actually understand what the hell they're trying to say, right? So this is a good example of a grammatically correct statement, but it actually just means nothing. It's nonsense, right? And so, what does this mean for gRPC? Why are you talking about this map? Well, why it matters is just because an old program can read new data and vice versa doesn't mean that, at the protocol level, it doesn't mean the application doesn't know about that. Like, the application still needs that data. So as a good example, let's talk about an event-driven architecture where you've got an ordering producer that's publishing orders onto a queue or topic. And you've got a consumer that's reading that off the queue, and it's going to tally up all the total orders and sum it up as a report or something, right? So it's going to read all the orders coming in, look at the total field, sum it all up. And let's assume we remove the total, or we put it into a nested field, or we split it into multiple fields. In any case, we've removed the total, and when the consumer reads it now, it's not there. Just because we can read it and it doesn't explode doesn't mean the application didn't need that value, right? So now we're going to get the wrong value for a total. So I hope that gives you a bit of a sense. But it gets much worse when you combine this with optional fields. Optional fields, yeah. So, read that first. Read that first and we'll work backwards to the point I'm trying to make. So in researching this talk, I spoke with somebody who worked at a large global payments company, and they were doing gRPC and Protobufs. And this strange bug was occurring where payments weren't being dispersed to merchants. And after a lot of debugging and digging and researching and painstaking debugging, they discovered there was a single service in the ecosystem that hadn't been updated to use this new field. Because what had happened is there was a merchant API that added a new property onto their update configuration, which basically said you should enable or disable payments to this merchant. And so all the consumers had updated except for one of them. And every time that consumer hit this endpoint, a default field went in for dispersed payments, and it was set to false. So every time they called this API, they kept turning off payments for that merchant. Of course, you can imagine the kind of, it's very nefarious, right? A master problem. And it's a really good example of why forwards and backwards compatibility doesn't actually solve this. And in this case, you actually would probably prefer for it to explode quickly so you could discover it really quickly. In fact, Protobufs has removed required fields altogether. And I think that's probably a bad thing in terms of comprehensibility of an API. Now everything is optional, which very much reminds me of SOAP. And yeah, you read the quote now. I think everyone's read the quote. So, let's go back to the problems here. We talked about semantics and optionals, but actually you can still introduce breaking changes even in the basics of the language. So, for example, field descriptors, in theory, very easy not to change. In practice, if you can refactor your code through IDEs, you can still do that. Transport layer safety, I might just skip past that just in the essence of time. But narrow type safety is a really good example of another one. So most of these things usually only have very weak types. So JSON, for example, has a number and a string, and a null, right, and objects. But oftentimes you want to narrow that to, for example, a date format that needs to be UTC formatted or a currency format, whatever it is. Those things are usually important, and they're normally not encoded in these protocols. Of course, we still need to think about visibility into our consumers' usage as well as coordinating those changes. All right, so hopefully you've seen a bit of a theme here, and whilst each of these technologies undoubtedly bring benefits, they don't actually solve the API communication problem. So let's return to contract testing to see why that's the case. The first thing I want to make here, or point I want to make, is your API specification is not the product, right? It is just a representation of the product. It's just one representation. We obviously work in abstract terms all the time, and it's a great thing, but you just need to remember it is not the product. And any observable change in the behavior of API will be basically deemed breaking by someone in your service community at some point, and this is an observation known as Hiram's law. So we can't make that go away, but what we can do is find ways to reduce the ambiguity. Yeah, it's a great quote. As an open source maintainer, I can relate. Contract testing can help bring that visibility and really shine a light on some of the shadows in those specifications. The first way it does this is the record and replay style of contract testing. And I should make the point here, contract testing is a general term, and Pact, I'm going to mix and match this a little bit because I naturally do. The general contract testing approach here is the same, and you can do this without Pact, obviously. But the record and replay style gives us true representative examples of what our consumers need against a real provider. So we get confidence they can actually work from that position. But we also get, via this specification by example, we reduce the ambiguity and we improve the API comprehension as well. One of the great things I think about this kind of technique, and especially if you store the data over time, is you basically get the ability to time travel. So by pairing the application versions that are producing contracts and the ones that are verifying them, we can build up all this data of the compatibilities over time. So now we can go, let's use this consumer against an old version of, say, a data pipeline. We want to go back and reread old files or new files from old consumers. And we can use the contract information to see if they're compatible. So this is really powerful in things like event sourcing or data pipelines, where you often will go back and look at old data. Transport concerns can be encoded in the contract. We can again encode those field level matches, the much more rich matches, into a contract. And of course, now we know what our consumers are doing with our APIs. We've got much more visibility into that, for one, which is usually helpful in a whole bunch of ways. But also, we can also try to avoid versioning. I just said also twice. Anyway, we can avoid versioning, which is a great thing because versioning is a pain in the butt. Well, we can often avoid versioning. So I hope you can see that contract testing as a general approach is sort of just a generalized way of helping us test data exchanges that works across transports and protocols and content types. So whether you're doing a RESTful API or you're testing Protobufs over gRPC or Kafka or writing an Avro to a file system, the question is the same, is can we communicate some data between systems over time? Well, while Pact doesn't have all these things built into it by default, you can actually now extend that through plugins. So Pact we built this basically plugin framework into our shared core, and we'll be rolling this out over the course of the next few months. That's currently supported in PactJVM and PactGo and JS very soon as well. And it basically means you can create any plugin for transport or content, what have you, and then make that available to just your team if you like, or you can obviously publish it as an open source kind of thing. And it means you can test much more rich sets of protocols and transports, or even custom ones. Like if you're working in banking, you might want to build an AS2805 a contract, for example. So let me summarize what we got through today. Microservices, multi-protocol, internal microservices, it's accelerating. And it's going to be the larger part of what's happening over the next couple of years. This lack of standardization, I think it's talked about a couple of times today, this lack of standardization for design and testing is really contributing to this challenge around microservices sprawl. We've talked about Hiram's law as well, and how that our API specifications are just a view or just one lens of what we think our product is, and that we need ways to reduce this ambiguity to provide a better service to our customers. And contract testing is one way that can give you increased visibility into your consumers' usage and really try to break down some of that complexity and shine lights on areas of the specification or what the specification doesn't cover. And that we also learned that Pact is a contract testing tool that implements that, and you can really use it as a standardized or general approach for contract testing across protocols and transports and whatnot. So thank you very much. If you'd like to learn more about any of this stuff, you can head to the blog or our docs. Of course, you can come and talk to one of us afterwards. And yeah, thank you very much for staying through. I know it's getting late. Hopefully this was something interesting.
Thanks a lot, Matt.
Oh yeah, just in here.
I think we've got time for one or two questions.
Great talk, Matty. Well done, mate.
Thank you.
Quick one. So for the companies around here, people in different new companies that are just looking to introduce contract testing, what are some of the tips or steps that we could follow and work to try and get it across the line and introduce it?
Yeah, good question. So the question was basically, what's the best first step to get started? I think the first one is usually finding a good piece of code base internally where you've got a team who's motivated behind the problem, who can actually do it and show what good looks like. I always think showing what good looks like is a good starting point. Sometimes you want to boil the ocean, all those kinds of metaphors, but starting small, getting one team to be successful and making good progress there and making a difference. Other teams will often want to follow that best pattern. I definitely saw that out at Seek when I worked there several years ago. I think they did a really good job of sharing knowledges between teams. That's probably my go-to starting point, especially if you can get the entire pipeline running. And then once you're really humming, that's a good opportunity to go, hey, maybe bring in another team and go from there. Thanks for the question.
Okay. One real quick one. Just on the testing side of things, how does the speed compare to when you're doing inline testing? Do you find that contract testing a lot faster, or?
Yeah, generally speaking, it should be. I mean, in theory, it should run as fast as a unit test. In practice, it usually runs a little bit slower, just because on the provider side, you'll tend to start the service locally. Yep. But because you're not going out over real networks and you're not working your way through dependencies, it's just between one and the other. So it's somewhere between. It's probably more of an integration test than speed. But I mean, in the latest version of Pact.js, for example, I think it was 10,000 tests in 3 seconds. So it still runs pretty quick. It's got Rust under the hood now.
Okay, thanks a lot,
Yeah,
Matt.
thank you.